Okay, so find the tangent line of f of x equals, let's say, 3x squared plus 2x minus 3. When x equals, let's go 1. This should be a nice problem. Okay, step 1. Take the derivative. So f prime of x is 6x plus 2. Step 2, plug in x. F prime of 1 is equal to 6 plus 2, which equals 8. This is your slope. I hope that's how you spell slope. Is that how you spell slope? S-L-O-P-E. I can't spell. I misspell my own name for crying out loud. So, okay, that's the slope. So now that I have the slope, I need one more thing besides my x value to be able to find the graph. I need a y. So I'm going to plug this into the original. Okay, so f of 1 is equal to 3 plus 2 minus 3, which equals 2. Right? So now, use y equals mx plus b. So I know that y is 2. I know that m is 8. I know that x is 1. And that makes it so I can solve for my b. So I'm going to minus 8, negative 6 is equal to b. So then I would have y equals m, which is 8, x minus 6, and I'm done. Everyone feel okay about that? Yep. Great. We are now going to do, I'm just going to put a note. So I need to add secant line. Do secant line example. I'll try to do one tonight when I'm scanning all this stuff and just email you it in the pages, okay? 6. Number 7. Okay, we're now on to test 2. Test 2, if you guys remember, had the triangle problem where you're like going across the water to the burning house and you have to save the house, hopefully. Also have to build the box problems. Also has the pretty much all the story problems you don't like. Yep. Does anyone have a book with them I can borrow? Yep. Wait, Sharon's right here in the front row. She's got it. Good. I'm just going to pull problems from here so that we already know that they work, because we don't have time for me to make up problems that work. Fair? Okay. I'll also tell you good problems to look at for our practice. Okay? They love to pull problems from your homework for your exams. Okay. Let's do this problem. Absolute extrema. Oh yeah, absolute extrema. I'm going to write that on here. No, I don't know what I want. 6.2, please. Okay. Find all and inflection points I think this is the one I'm thinking of.
Did you like the gangster? No, dude.
So, So what our steps are, they're the exact same thing for your first derivative test and your second derivative test. The only difference is what they mean. So here's your steps. Number one, you're going to take the derivative. Okay, so let's take the derivative. I'm gonna do this in columns because I think we're gonna need column. Like I'm gonna divide our paper. Okay, so we've got the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. I'm gonna simplify this. X squared plus 1 minus 2x squared over x squared plus 1 squared, which would be 1 minus x squared over x squared plus 1 squared. Okay, step 2. Set top and bottom equal to 0. Solve for critical points. Everyone with us? Not very clear, is it? But at least there's room for everyone. Okay, so I'm going to say 1 minus x squared equals 0, and x squared plus 1 equals 0. This would give me 1 equals x squared, so x equals plus or minus 1. This one never equals 0, because when does x squared equal a negative 1? Never. Yeah, imaginary numbers if you don't care about in this class. So these are my points. 3, you make a number line, plug into the derivative, very important, into the derivative, and interpret. I hope that's how you spell interpret. I don't have a clue. I should really just memorize it. It can't be that hard.
You got it.
Okay, thank you. So now I'm going to go from here, this derivative, because it's the more simplified version, and plug in a number above, between, and below into the derivative. So if I plug in 0, is it positive or negative? Positive. If I plug in 1, well, I can't plug in 1. If I plug in 2, is it positive or negative? If I plug in negative 2, is it positive or negative?
Negative.
Notice that the bottom is squared, so it's always positive. Also notice that 1 minus anything greater than 1 is going to be negative, right? So, what does this negative mean? It means the slope is going down or that it's decreasing. This positive means it's going up, and this negative means it's going down. So I don't know much about the graph, but I know it's going down, up, down. Cool? So what's at negative 1? A minimum. What's at positive 1? Maximum. Good job, guys. So you guys do remember a lot of this stuff. We just need to blaze through it, and hopefully it will help. Okay, so now that I know that that's that, if I plug in negative 1 up here, I'm going to get a half. And if I plug 1 in up there, I'm going to get a half. Actually, I'm going to get a negative a half if I plug this in. So I have a minimum at negative 1, negative 1/2, and a maximum at 1/1/2. Whenever you're doing points, you're always plugging the x value into the original to get the y value. Make sense? A point is always from the original. Okay. So now that I have this, we're going to do derivative 2, or the second derivative, to tell us concavity, right? That's a good question.